Okay. So yeah. So we will start now with the discussions on the content of the course, which starts with an introduction to signal processing. Actually, your course title is kind of weird. Okay. It's kind of weird kasi the CHED CMO, the one that regulates yung mga course offerings under a curriculum, under a program. Okay. Specifies that that this course is to be called signals, spectra, and signal processing. I mean, signal spectra and signals processing. Okay, yun talaga yung tawag nung CMO. Okay. But when you take a look at what the CMO prescribes is most of its this content actually concentrates more on what we call digital signal processing. Okay, sa ibang programs, ang tawag sa course na to specifically is digital signal processing, not this one. Kasi pag sinabi yung signal spectra and signal processing, it actually covers both analog and digital signal processing. Okay? But in this case, your course specifically, I mean the course content, okay, specifically the CMO from CHED specifically tells us that the discussions would be centered around digital signal processing. Okay, why is it called signal spectra and signal processing? Is something that really medyo it bothers me actually kasi nga kung ako lang yung masusunod, I would have discussed both analog and digital signal processing under this course. Pero ang pine-prescribe nga lang talaga ng CHED is yun nga, DSP lang. Okay. But anyway, at the end of this topic, we would be oriented with what your course is all about. Okay. Specifically yung terms na signal spectra, okay, at saka signal processing. Although I haven't dito sa topic natin, I haven't yet defined what is a spectra. Okay, pero siguro later on baka mabigyan ko kayo ng konting sneak peek on what spectra or spectrum, yung singular form niya. Spectra kasi is plural. Okay. What spectrum is all about. Okay. So let's discuss ito nga. Let's start with the lesson here on signals, systems, and signal processing. Okay, so DSP is an area of science and engineering that has developed rapidly over the past 30 years. Basically, DSP is not a new field in engineering, specifically in electronics engineering. It may have been offered as a course in ECE just recently. In fact, sa pagkakaalala ko, batch namin ang unang kumuha ng course na to sa curriculum ng ECE. Okay? Ang tawag namin dito noon is signals, spectra, and signal processing. Iba yan sa tawag nyo ngayon. Kasi sa tawag nyo ngayon, ang tawag nyo ngayon dito is signal spectra and signal processing. Okay? So basically, sa amin nung kinukuha namin to, when we are taking this course, we are dealing with three concepts. The concept of signal, the concept of spectra, and the concept of signal processing. Sa inyo, dalawang concept lang yung kino-cover. Signal spectra and signal processing. Although sa amin has a fault of not putting in an Oxford comma here. Okay? So yun yung isang weird thing about that. Anyway, so naalala ko kami ang unang batch namin ang batch 2001, yung unang kumuha nito. Okay? Nitong course na to under ng ECE. But this has been a field, a known field. Okay? In computer science, excuse me, in computer science and and in other fields of engineering. Okay, especially in computer engineering. Okay. Although sa pagkakalam ko rin, bago lang din in-offer sa kanila tong course na to. Okay. So, many of the signal processing tasks were conventionally performed by analog means are realized today by less expensive and more reliable digital hardware. Okay. Show hands nga dito, who among you have been able to take principles of communications or kumukuha ngayon ng principles of communications? Wait lang, baba mo na ulit. Sino yung nakakuha na? Yung tapos na sa principles of communications. Isa pa lang. So, sino yung kumukuha pa lang ngayon? Ay, sorry. Sige, baba ulit, baba. Sino yung kumukuha pa lang ngayon? Currently, ngayong term na to. Okay, so sige. So, maybe some of you might have not have an idea kasi it's either nalipasan nyo na, baka nakalimutan nyo na ibang konsepto o kaya ngayon nyo palang pag-aaralan. But a central idea or a central concept around electronic communications is how we actually process your signal. Okay. For example, isa sa pag-aaralan nyo sa principles of communications or isa sa napag-aralan nyo, one of the things that you have studied in the principles of communications is yung concept of modulation. Okay. And basically, modulation is a process by which a characteristic of a carrier signal is varied or modified by a characteristic of an information signal. Okay, so that's basically that's generally the definition of modulation. So which means you are dealing here with a signal, okay, the carrier signal, whose characteristic, okay, is varied by another characteristic of another signal. Okay, and for you to do that, you need to do some processing. Okay, you need to do some processing. Okay, you need to perform signal processing. Practically, this is called processing. Okay, practically this is called processing. Pero in theory, okay, in theory, this processing is basically performing a mathematical operation on signals. Okay? So in practical in practice, okay, we will be designing circuits, okay, in order for us to carry out, okay, the process. Okay, in this case, for example, modulation. Pero in theory, okay, there is an underlying mathematical operations that have been performed on that signal or on the signals in order for you to come up with an output. Okay, so in this case, for example, sa case ng modulation, ang modulation is basically a process of multiplying two signals. Okay, if you have two signals that you want to modulate, okay, if you want to modulate a carrier signal using an information signal, basically you have to multiply those two. Yun yung underlying mathematical operation. Pero in order for you to carry out that in practical or in practice, okay, you would be needing a circuit for that. Okay, and in the past, So sabi natin, you need a circuit. Okay? For example, this would be your circuit, no? This would be your circuit that would carry out a modulation. So basically, you would have two inputs. Okay? Dahil meron kang carrier signal and you have an information signal. Okay? And on its output is the modulated signal. Okay? Now, before, this circuit is essentially analog circuits. Ito, sigurado naman ako tapos na kayo ng electronics nito. At least electronics 1. Am I correct? Electronic devices. Okay, at least you're done with electronic devices. And some of you might be taking up electronic circuit analysis and design. Is that correct? Or tapos na rin kayo? Taking up siguro. Malamang taking up that. Okay. So, you're carrying out these operations or these processes, okay, using analog circuits. Okay. Probably using FETs. Okay. And bago pa nga merong FETs, ano pa yan? Capacitor, inductor, circuits pa yan. Way before magkaroon ng FETs. Okay? We've been using capacitor inductor circuits in order to carry out this operation or this process. Okay? But in the advent of the invention of transistors and the use of transistors and the subsequent use of transistors in terms of in switching. Okay? So nalaman natin, no? Ang transistor ninyo is not only for amplification, okay? It's not only for amplifying signals, but it's also useful for switching, okay? It can be used for switching. For example, in the case ng BJT, you can set this to 3 states or 3 operation modes. It can be set into cut off, can be set to saturation, and it can be set off to, ano yung isang operation ito?
Active, sir.
Active. Okay, yung active mode. Okay. So, in these three states, when does your BJT act as an amplifier? And when does your BJT act as a switch? Based na pag-aralan nyo sa devices natin. When you have a BJT, okay, in what mode, okay, will you have to put in your BJT in order for it to act as a switch and in order for it to act as an amplifier? Ano yan? Basic yan ng ECE. Dapat alam niyo yan. At mumultuhin tayo ng mga inventors ng mga transistor kapag natin alam yan. Kailan natin ginagamit ang at what mode do we use BJTs as amplifier? And at what mode do we use them as switches? Oh, walang may idea.
Amplifier po sa active region, sir.
Okay, correct. So kapag nilagay nyo or if you bias your BJT in active mode, it can act as an amplifier. It can amplify small signals. Okay? It can amplify small signals. Small meaning yung yung frequency niya is not is just within the operating range of the BGT. Okay? And obviously itong dalawa, okay, is the mode that we put on our BGT in order for it to act as a switch. Pag nasa cutoff siya, it can act as an off switch. Okay? Pag nasa saturation naman siya, it can act as an on switch. Review nyo to sa sa electronics niyo. Okay? So, aside from using your BJT, okay, as an amplifier, dahil nga ang mga BJT rin, okay, can have, or not just BJT but also FETs, and most especially FETs, MOSFETs, okay, CMOS, okay. Most of them can act as switches, and the manner by which yung processes by which these transistors can actually be integrated, okay, can actually be integrated on a large number of them can be integrated on a small area. For example, an area of this small, ganyang kaliit na area, you can actually fit 1 million transistors there. And of course, all of them are switches. Okay, wala diyang magiging amplifier. So all of them are just switches. So in this small area, you can actually fit in 1 million transistors. Yung processes, okay, yung processes by which this made possible also led to the development of the computers. Okay? So these computers now enable us to do more operations, okay? To do more operations, but there is a catch. Okay? Yung mga signals, okay, that we use to process using analog circuits now needs to be digitized. Okay? So in order for you to process a signal, okay, using computers, okay, or more specifically, these are called digital signal processors, okay, which are basically computers din, okay. There is a need for you, okay, to convert analog signals, okay, to convert them to digital form. Kasi hindi mo naman mapaprocess ang analog signal into digital using a digital processor, because digital processor can only process digital signals. Okay? Now from there, this manner of processing your signals, whether yung old school na modulation or some other signal processing before that are more popularly done using analog means, okay, have now a digital counterpart. Meron na silang digital counterpart na tinatawag, okay? And these are all made possible by the technology by which we can actually integrate transistors into integrated circuits, okay, and thereby allowing us to construct powerful processors or computers in order for us to be able to perform these kinds of digital signal processing. Okay, malinaw ba 'yun? Now, I don't know with you, no? I don't know with you. I don't know with your generation. Okay, I don't know with your generation, but your generation kasi hasn't been exposed to analog technology. Okay, so nung panahon kasi namin na inaaral namin ito, we've been exposed to both analog and digital technology. So alam namin yung fundamental difference nila. And there is this prevailing thought before that when something is digital, it must be expensive. Meron din ba kayong ganong impression? Do you have that kind of impression pa ba? So, wala nagre-react. So, I'd assume wala. Kasi, which is understandable naman. Okay. Understandable naman on your case because I don't think you've been exposed to analog technology enough. Okay. In order for you to make comparisons between the two. Okay. But just in case, we have been trying to digitize most of our processes in communications, especially in signal processing. Okay. But it actually does not turn into cost. Okay. In fact, at this point in time, digital signal processing is actually less expensive than analog signal processing. Okay? Or any other signal processing methods. Okay? In fact, actually mas popular ngayon actually ang yung tinatawag na mixed signal. Okay? Mas popular ngayon yung tinatawag na mixed signal processing. In which in one circuit, okay, or in one board, you are processing both analog and digital signals. Okay, so yun ang mas ngayon, mas tinitingnan na technology ngayon. What we call yung mixed signal processing. But we'll first focus on digital signal processing by itself muna. Okay? So digital signal processing is a costless, okay, than analog signal processing. It is more reliable. Okay, it is more flexible. Flexible in terms of sabi ko nga sa inyo, yung ginagamit to process, okay, yung ginagamit ninyo to process your signal is basically a computer. Now, what is good thing about this one is that this can be general purpose computer. Okay. Pwede siyang general purpose. Pwede rin siyang specific purpose. And if the processor is a general purpose processor, okay, it means it can be reprogrammed. Okay. This can be reprogrammed. Okay. In order for it to do an entirely different task. Okay. Not only that, it can also perform simultaneous different tasks. Pwede siya mag-perform ng iba-ibang tasks. Okay. Due to the computing power. Kung possible, if it is possible that if the computer allows you if the computing power of the computer, okay, allows you to program it in such a way that it can perform parallel tasks. Okay. Then mas maganda. Okay. So that a single computer, for example, can actually take in many signals, many input signals from various sources, and then can produce many output signals. Okay. Each having undergone different operations. So possible yan. That is why digital signal processing offers flexibility. Okay. Hindi yan katulad ng analog signal processing that if you design a circuit, okay, that specifically say does modulation. Pang modulation lang talaga siya. So kung gusto mong gumawa ng, for example, analog to digital circuit, gagawa pa ng ibang analog to digital circuit na na board para doon. Okay? Is that clear? Okay. And high accuracy and precision. Okay. The one thing that you have to remember about digital signal processing is that it processes estimates of the real signal. You have a real or analog signal. Ito. You have an analog signal here. Okay. Which is the more accurate, which is the real life signal. Okay, that's the signal basically that you read galing sa environment or galing sa labas. Okay? But when you pass it through, say for example, an analog to digital conversion, analog to digital converter. Okay? That analog signal becomes an estimate. Kasi lalabas dyan actually is the digital signal. This is called an analog to digital converter. Okay, when you see this symbol, that A/D, it means analog to digital converter. Okay, so lalabas dyan is basically a digital signal. And that digital signal is basically an estimate of your analog signal. So what the processors would process is basically an estimate of the analog signal. Okay. But here's the point that I would try to make. Even if your digital signal processor, okay, would process an estimate of an actual signal, of an actual analog signal, okay, it would still overall carry out the process in a very accurate and precise manner. Okay. Number one, again, because ito in the case of the processors, since you can program it, you can actually minimize the errors. You can introduce something, okay, into the program or into the instructions to the processor, so that the errors, okay, that are encountered when, okay, your signal has been converted from analog to digital, and later on from digital to analog, kung kailangan natin siya i-convert pabalik, okay, can be minimized. Okay, so you can do that. Okay, also, yung conversion from analog to digital can now be as close as possible, can now be made as close as possible. Okay, because of again the computing power of the processor. Before, okay, we can only say, for example, represent signals using 3 bits or 4 bits or 5 bits. Okay, but now we can represent signals up to 64 bits. Okay. Kumbaga, yung conversion from digital to analog, from analog to digital, now has a very, very, very minimal error. Okay. And although we cannot credit that on the digital signal processing itself, we can actually credit that here sa analog to digital conversion. So yung circuits na ginagamit in order for you to convert analog signals to digital can now be more accurate in terms of the conversion, so that the error between the analog and the digital representation is very, very small. Tapos yung processing pa, okay, can actually be made or can actually be programmed in order for that error to be minimized further. Okay, so that is why relatively, okay, mas accurate ang digital signal processor or processing kaysa sa analog signal processing. Okay, is that ano? Is that clear? Any questions so far? Okay, so wala naman. Okay, so let's define some terms, no. So a signal is defined as any physical quantity that varies with time, space, or any other independent variable or variables. Okay, so let's say here a signal S1T equals 5T. Okay, it's a signal that varies linearly with T. Although we don't know what T is. Okay, pero in this in all throughout this course, that small t it will be used to represent time. Okay? So dito kasi wala pa sinabi, dito sa example 1.1.1, walang specific na sinabi ko na yung variable t. Okay? But I'm pointing out now that all throughout this course, okay, when we are using the small, the lowercase t as a variable, we're using it to depict time. Okay? So which means that this signal is a signal that varies linearly with time. Okay? So, yun. While this signal, okay, 20t squared is a signal that varies quadratically with t squared. Okay? Now, the signal S3, x of y, okay, which is this one, okay, describes a signal dependent on two variables, x and y. Okay. Again, wala sinabi ko na yung x and y. Okay? But in most cases, I'm not saying na in all cases, but in most cases, this x and y would actually depict spatial coordinates. It means Cartesian coordinates, spatial or spatial. I prefer to pronounce it as spatial kasi. Okay? Which means x coordinates siya. Okay? I mean Cartesian coordinates siya. Ito yung x number line, ito yung y number line natin. And then this signal, okay, varies as you change your x and y, this signal x3 is defined. So if you are to imagine this is actually a three-dimensional with the S signal, yung value ng S signal niyo is represented on an axis. Ano natin siya? I-correct natin siya. So ito yung ito yung x axis niyo. Ito yung x number line niyo. Ito yung y number line niyo. Tapos ito yung value ng signal niyo, S3. Okay? So in order for you to define S or to compute S, you need two values. Yung values ng x at saka yung values ng y. Is that clear? Is that clear ba? Okay. So yun, mostly ganun yung meaning nung x at saka y na natin, na variables natin. Actually minsan x, y, z yan. Okay? Pertaining to a three-dimensional spatial coordinate. Okay, or coordinates. Okay. Tapos meron siyang fourth axis which tells us yung dimension, yung value ng signal. Okay, using the three coordinates. Okay. So it tells us how your signal varies according to space. Okay. Ito kasi in this case, this is according to its space, in its position in a plane. For example, ito yung isang value ng S3 ninyo. Okay. Say for example, this is x1. This is y1. So yung value ng S3 dito is essentially x1, yung value ng S dito is essentially for x1 and y1. Okay, and then if we have another value here, say, dun sa kabila, para medyo kita ninyo. Here. So, we will have here ito, tsaka ito. So, you have here S3, X2, Y2. Okay, so the value of your S3 actually varies depending on depending on the position of a point on this plane is. So essentially, yun yung sinasabi nung signal na to. But in these three cases, okay, in these three cases, ito, ano yung napansin natin sa mga signals na yan? What do we notice about these signals? Nung hindi nyo pa pinag-aaralan yung signals, ano ang tawag yung sa mga yan?
Function po.
Yes, they are called mathematical functions. Okay? So, nung hindi pa kayo nag-aaral ng signals at ang pinag-aaralan nyo pa lang ay math, when you are studying just math without applications pa, okay, you're calling these three mathematical functions. Okay, you're calling these things mathematical functions. Okay, but now we're calling them signals because we are in signal processing. But essentially, what I would like to point out is that your signals are essentially mathematical functions. Okay, so you have to remember that signals are essentially or are fundamentally mathematical functions. They can be one-dimensional function, just like S1 and S2, or they can be two-dimensional functions. They can actually be three-dimensional functions. Okay, is that clear? Now, there are cases when a functional relationship between the dependent variable and independent variables is unknown, okay, or too highly complicated to be of any practical use, which means it would not enable us to describe the relationship between the independent and the dependent variable in a explicit, compact way. We will not be able to describe the relationship between the independent variable and the signal, okay, in a concrete way. Okay? One example of which is yung speech signal. Okay, one example nung kung saan hindi na rin kayang i-define yung signal using a concrete, a compact, an explicit mathematical function, okay, is the speech signal. Okay. Now, what do we know about speech signal? Ang alam natin sa speech signal is this. At any given period in time, or at any given very short period in time, okay, a segment of a speech, okay, would consist, okay, of a sum of several sinusoids of different amplitudes and frequencies. Okay, so which means yung speech signal natin or yung lumalabas sa bibig natin whenever we are trying to talk, okay, can actually be represented by by sum of sinusoids. Okay, by sum of sinusoids having different amplitudes, different frequencies, okay, and different phases. And these are all instantaneously coming out as we speak. Okay? For example, when you pronounce when you speak out the term or the phrase algorithm, algorithms, and devices. Okay. When you're speaking out, yung when you're producing the al sound, ito yung lumalabas. Okay, yan yung lumalabas. Now, this moment na medyo silent siya. Okay? It's because you're not actually emphasizing the speech on G, but rather on O, algo. So yung power ng speech ninyo hindi wala sa G, nasa O. Okay? Medyo binabago niyo lang yung position ng dila ninyo in order to produce this G sound, algo. Okay? Pero yung power nung speech signal niyo is more on nasa O, not on G. Okay? Pero let's concentrate first on A and L. Now, as you can see, okay? As you can see, this signal doesn't look like any of the familiar functions that we know. Okay? This is not really familiar with us. And what we can just say is that this is simply a sum of different sinusoids having different amplitudes and different frequencies. Okay? This is what we call complex signals. Okay? And basically, complex signals are sinusoids or sum of sinusoids. Okay, having different amplitudes and different frequencies. Okay. And with that, okay, we will not be able to really produce we will not be able to produce a concrete relationship between time, okay, and the variation in amplitude and the variation in frequency. Okay, other than that, we know na ito nga siya. Okay. Although ito ang magagawa natin. And this is what is a point of study, a point of research in speech. Okay. Not only not only in the side of engineering, but also on the side of linguistics. Okay. Familiar ba kayo sa tinatawag na tonal languages? Ay narinig niyo na 'yan? Hindi pa. Nanonood kayo ng Korean novela? Sila ang umamin Ayun. So, sige. Kung nanonood kayo ng Korean novela, naririnig niyo yung syempre hindi niyo masyadong pinapansin yung naririnig niyo. Ang pinapansin niyo syempre yung subtitle, tama ba? So, pero here's an interesting fact about the Korean language, and not just Korean language. Korean, Chinese, Japanese. Okay. Anime, nanonood kayo. Naruto, One Piece. Ayan. So, again, hindi kayo masyadong nakikinig dun sa naririnig yung language. Mas nakakonsentrate kayo dun sa dun sa subtitle usually. Okay. But these languages are what we call tonal languages. Okay. Why do we consider them as tonal languages? Actually, Filipino is part tonal. Okay. Medyo tonal language din ang Filipino language. Hindi lang kasing tonal nitong mga to. Okay. Why do we consider them as tonal languages? It is because for you to give meaning when you are speaking the words, for you to give meaning to a word, two things must be or you have to put the meaning into aspects of the speech. Number one, yung syllable na gagamitin ninyo. And number two, the tone by which you speak. Yung intonation. Kung gaano siya kataas or kababa. Okay. Dahil kapag you speak the same syllable, okay, using any of this language, you speak the same syllable, but you say it in a different tone. The meaning is the meaning might be interpreted differently. Actually, sa Filipino language, meron din tayo niyan. Wala akong maisip ngayon pero ito. Puno. Tsaka puno. So, puno. Ano mas mataas? Puno. Tsaka puno. Magkaiba yung tono nito at tsaka nito. Sa dalawang magkaibang na yan. Sa dalawang magkaibang words na yan. Ano yung ibig sabihin ng puno sa English? Pag-translate niya. Puno. Wala, hindi nyo alam. Ay, yung puno. Baka mas alam niyo yung puno.
Yung puno po, 3, tapos yung puno, full.
Ito, 3. Yan. Ito, full. So, pansinin nyo na magkaiba yung tono nung mga syllables. Kasi ito, puno. Okay? Kasi ito, puno. Sa Filipino, sa pag-aaral natin ng Filipino, ang tawag nyo dyan, yung diin. Kung tama yung pagkakaalala ko sa Filipino ko rin. Yung diin. Pero actually, tono yun. It's actually more of a tone. Okay? Ganun din sa language ng Korean, ng Chinese, at ng Japanese. So if you actually are trying to say words in these languages, you really have to capture pati yung tone by which they do it. Kasi if you don't do it properly, your speech might be interpreted differently. Okay? Now, ano yung relationship niyan dun sa sinasabi kong research that is undergoing on linguistics? When you're trying to detect say for example Korean speech, o kaya Chinese speech, o kaya Japanese speech, kumbaga kung i-convert mo siya for example from speech to text, okay, in order for you to do that, okay, one aspect of your converter should be able to measure those tone. Kailangan ma-measure nyo yung tone na yun. Halimbawa katulad nito. Kapag gagawa ko ng Filipino speech to text Filipino speech to text converter. Okay. In order for me to correctly interpret kung ano yung 3, okay, at ano yung full, okay, I need to measure properly kung alin yung mas mataas na tono kaysa dun sa isa. Okay, alin yung mas mataas na tono dun sa pu at saka dun sa no. Okay? And that measurement of we call that measurement of what we call the fundamental frequency. Because every speaker has what we call a fundamental frequency. So tinatawag tayong fundamental frequency dun sa bawat nagsasalita. Kaya nyo nakikilala ang isang tao kahit na hindi nyo siya nakikita pero nagsasalita siya. It's because of that fundamental frequency. Meron siyang characteristic na tono. Pwedeng yung overall voice niya mababa. Okay, katulad ng sa akin. Okay. O kaya, pwedeng yung characteristic na boses niya mataas. Yung kahit na hindi naman siya sumisigaw or kahit hindi naman, mataas talaga yung tono ng boses niya. Okay. So, every speaker has that fundamental frequency. Okay. And that can be measured. Okay. That fundamental frequency can be measured. Okay. In fact, baka later on, okay, that would be one of the things that we will have to do. Okay, sa activity niyo sa laboratory. So how do we measure fundamental frequency sa speech? Okay? Is that clear? So okay, good. So while we don't have an idea on the exact relationship between time and the speech, the amplitudes of the speech signal, what we know of is that we can characterize this using what we call fundamental frequency. We can measure it. Okay? And for us to be able to do that, ito, i-define natin yung isang part ng course title niya na hindi ko na-define dito sa lesson na to. For us to be able to do that measurement, we need what we call spectrum. That is in singular, or spectra sa plural. Okay. Spectrum or spectra is actually the frequency components of a signal. Okay? If you actually measure your signal in the frequency domain, okay? Yung mga values na makukuha nyo doon is what we call the spectrum or the spectra of the signal. Okay? Ang tawag natin dito, ito, is waveform. Okay? Waveform is measured in time domain. When you look at your signal, when you look at the variation of your signal in time domain, okay, you're looking at the signal's waveform. But if you're looking at the variation of your signal in frequency domain, you're looking at its spectrum. Is that clear? Now, saan ba nanggaling yung term na spectrum na yan? It actually came from alam niyo yung prism? Glass prism. Tig lang. Kuha tayo na dito. Familiar kayo sa experiment na to? Or hindi nyo na nagawa nung high school or sa physics class niyo? Sa bagay, ano nga pala yung physics niyo, no? Yung nag-lockdown na. Okay, anyway, the experiment goes like this. Meron kayong glass na prism. O kaya kahit ano to kahit water lang to, water droplets. And then when a white light passes through it, okay, what happens is that this prism actually separates the light into component colors. Yung component colors na yan yung Roy G. Biv ng rainbow. Okay? And in fact, ito yung tinatawag na spectrum. Okay? This is what we call the visible spectrum. Okay? So, the visible spectrum consists of different colors of light. And actually, the color of the light that you see is actually dependent on its frequency. Kung babalikan niyo yung physics niyo, light is both a particle and an electromagnetic signal or an electromagnetic wave. Kung titingnan natin siya sa electromagnetic wave, meron siyang frequency. So kung meron siyang frequency, yung frequency na yun would actually correspond to a color. With, sige, saka natin pag-usapan yung kung ano yung mataas tsaka mababang frequency. Okay, pwede nyo namang alamin na lang on your own. Okay. Another signal that we cannot ascertain the relationships of is yung ECG. Are you familiar with ECG? May na-ECG na ba sa inyo before? Okay, so mukhang wala pa, no? Kung wala pa, ang ECG is what doctors use in order to diagnose diseases of the heart without actually looking inside the heart. Ito yung ito yung parang pinaka simplest way. This is the simplest way of looking at the condition of the heart based on the signals that based on the electrical impulses that the heart is sending every time it beats. Okay? Pagka medyo malala talaga yung sakit niya sa puso, from ECG, ginagawa yung 2D echo. Okay? Pero it has some form of ECG pa rin. Again, we don't know the exact relationship between this signal and actually this is based also on time. So waveform pa rin ito. Okay, so this is actually this signal evolves over time. Okay? So yung bawat box na yan represents a certain time interval. Okay? And the doctors read those signal. Now, kung mapapansin niyo, marami siyang waveforms. It's because the doctors place multiple electrodes on your body. So they place it on your thorax, on your abdomen. Minsan meron tinatawag na 12 lead ECG in which doctors place 12 plus 2 electrodes on your body. Plus 2 kasi yung dalawa para sa grounding. Yung dalawa na yun nasa paa nyo, sa may ankle. Okay, doon nilalagay yung yung parang pinaka-grounding niya. Okay. So ito lang to. 6 lang to. Okay. Sometimes they place in 12. Okay. So doctors use this signal in order to diagnose heart problems. Okay? So aside from speech and ECG, marami pang naturally occurring signals, okay, that bear information. Okay. By the way, iba ang signal. I would like to emphasize this one. Iba ang signal at iba ang information. We will have to be technical about this, especially later on. Although in this discussion, in our discussion in this course, mostly overlapping tong dalawang to. Pero in some cases, we will have to differentiate them. Okay? A signal may or may not carry information. Okay. For example, yung nakita nyong signal kanina na S1 of t equals 5 of t is a signal. But it might not carry information. Okay. It might not carry information. So, it is therefore, it should be you should be able to understand na magkaiba yung dalawang yan. Okay, it should be very clear to you that dapat napag-iiba niyo yung dalawang yan. Okay. You can have a signal, but that signal may not have information. Okay. But essentially, all informations are signals. Okay. All signals that carry information are information-bearing signals. So therefore, if there is information, or if there is some kind of information that we can read from something, okay, then we can say that is an information-bearing signal. For example, yung nakikita nyo sa screen nyo ngayon, okay, yung nakikita, itong text na nakikita nyo sa screen nyo ngayon, this is an information-bearing signal. Because you can take information out of it. Aside from the content. Yung mga black na text as opposed to sa white na background actually depicts words which would, pag binasa nyo, would give information. Okay? what you hear from this broadcast is also an information bearing signal. Okay? Because as I teach this, gumagamit ako ng iba't ibang speech patterns in order for me to convey information to you. Okay? But if I actually just send in, say for example, a tone signal. Wait lang. Can you hear that? May narinig ba kayong something? May narinig kayo? Wala, no? Wait lang. Ayan, may narinig kayo? Okay. Ganito. May sinasabi ako. I'm using different speech patterns in order for me to convey information onto you. Okay? So, may nadidinig kayo. Yung sinasabi ko is being interpreted by you as information. Pero ito, pag naririnig nyo to, you hear something, but that doesn't have an information. Because it doesn't tell anything. You just hear something, but it doesn't tell anything. Okay? So, yun. Kahit na ibahin ko pa yung tono niyan, huwag masyado mataas. Yun. Sakit, no? Taas eh. Yan. Or babaan natin yung tono, which you won't be able to hear dahil mababa yung tono. Okay. So again, these things don't carry information. These tones don't carry information. Okay? Although they have a sound, okay? They have a sound that you hear. Okay? But they don't carry information. So tandaan natin na technically, okay, magkaiba ang signal sa information. Okay? Signal and information are entirely different things. Okay? But in this course, and in most contexts that we will have to deal with in this course, these two are the same. So we will assume that all signals that we will consider carry information. Okay? Is that clear? Okay. So associated with signals are systems, okay, that respond to a stimulus to produce a signal. This stimulus system combination is called a signal source. So basically, in order for you to read signals, okay. Hindi lang basta dapat yung signal siya nag-occur sa environment or it can be generated. There should be something that would actually generate that signal. For example, familiar kayo sa seismic signals? Do you know what seismic signals are? Familiar kayo dito? Ayun. These signals are actually ano? Ano 'tong mga signals na 'to? Si Miss ano? Asan si ay, sorry. Si Miss Aguilar, anong alam natin dito sa ano, seismic signals?
Yung sa pagkuha po yung sa mga earthquake po, sir.
Yun, very good. So, these are signals that are taken due to the shaking of the earth. Okay? Kaya lang kasi kapag ka nag-shake yung earth, hindi naman automatic na i-interpret na lang natin yung shaking of the earth as something eh. Okay? Hindi pa yun yung seismic signal. So yung shaking of the earth, kailangan mabasa pa yan ng tinatawag na sensors. Okay, in this case, pwedeng accelerometer. Okay? Pwedeng accelerometer para ma-generate yung tinatawag nating seismic signals. So ito yung tinatawag natin ngayong signal source. This is what we consider as the signal source. Okay? Halimbawa, speech. Kung nag-uusap lang tayo, okay? The speech signal is generated by variations, by shaking of your throat, by the placement of your tongue, by how you push your air out habang nakapwesto yung tongue mo on a certain position and so on and so forth. Okay? So yung signal source ng speech is basically yung source ng air mo plus the throat plus the mouth. Okay? Pero in this case, since hindi tayo face-to-face, okay? We're not on a face-to-face meeting. You hear me through what we call a mic. Okay, yung microphone. Kasi yung microphone na nagko-convert ng speech signal ko, okay, into electrical signal that can be sent into your end. So basically, in this case, ang signal source ngayon is yung ako plus yung speech generating body parts ko plus yung mic. So yun yung signal source natin. Okay? Naintindihan yan? Okay. Now, different from that system, okay? Yung different from that system are system also that performs an operation on a signal. So iba pa yun dun sa system that actually generates your signal. Katulad nga ng in this case, itong accelerometer. So iba pa to. Itong system na to is a different thing. Okay? Now this system is a physical device that performs an operation on a signal. Okay? When performing operations on a signal processing takes place. Now, the system may also be called a signal processor. So, tulad ng sinasabi natin kanina, okay? In order for you to process your signal, okay, in order for you to process that signal, you need a processor. Okay? Now, in this case, generally, we will use the term system, okay, in order for us to describe that processor. But equally equal term is yung processor nga. Okay? Kasi ang system mas kino-cover niya general field. Okay? May tinatawag tayong control system. Okay, may tinatawag tayong filter system and so on and so forth. So, system describes a a device, a device which is either hardware alone or a combination of hardware and its programming, okay, which is whose task is to manipulate the input in order to produce an output. So yun yung system. Okay? Pero general yun. Okay? But sa context ng pinag-uusapan natin, in the context that we are talking about, we can also call these systems as processors. Okay? So, and when your processor processes a signal, okay, tulad ng sinasabi ko kanina, there is an underlying mathematical operation that is being done into your input so that the output can be produced. Okay? Maliwanag ba yun? So, tingnan nyo mabuti ito ha. Drawing natin yung general block diagram ng isang signal processing system. So, ito siya. Okay. Kailangan nyo ng input dyan. At ang input nyo dyan ay signal. So, signal input. Okay. Tapos, magkakaroon nyo ng output. So, signal output. Ang tawag natin dito, system or processor. Okay. Kanina, yung signal natin is considered as as a mathematical function. Tama ba? We consider these signals as mathematical functions. Di ba? Now, itong processor na to, okay, the processing that the processor does to the signal input are basically mathematical operations. Okay? Which will produce, again, mathematical functions. So, sa standpoint ng mathematics, sa theory, okay, signal processing is actually a familiar process to us. That is, meron kang input function, gawan mo siya ipag-perform ka ng operation sa kanya, magpo-produce ka ng panibagong function. Pero dahil meron tayong application dito, which is signal processing, then the input is called a signal. Okay? The one that performs the operations is called the processor. And the output is also called a signal. So, ito yung from mathematical viewpoint, ito yung from applications viewpoint. Makikita nyo, wala namang pinagkaiba yan dun sa So, that is why, what I need you to understand here is, you should be able to look at the signal processing as as a something na gumagawa kayo ng mathematical operations on a signal in order for you to produce another signal. Simple as that. So every operations na gagawin natin on a signal, on a given signal, should be interpreted as something that would produce another signal. Okay? And that operations is basically the signal processing that we are trying to talk about. Is that understood? Okay, so itong part na to medyo na-discuss ko to ng medyo paulit-ulit kanina. Pero dadagdagan ko lang ng konti yung iba kong discussion. Okay, so most of the signals encountered in science and engineering are analog in nature. So lahat ng mababasa yung signals that we would like to process, okay, are analog. Okay? So such signals may be processed directly by analog means. Okay? Although ang kailangan yung gawin dito is that you need to in this case, you need to form a what we call yung signal stimulus combination. Ibig sabihin, kailangan meron kayong sensor in order to measure the analog signal. For example, your analog signal processor cannot measure speech directly or cannot process speech directly without you converting the analog speech into electrical. And for you to do that, kailangan nyo ng mic. Naintindihan nyo? So one task that you need to do whenever you are trying to design a signal processing system is to actually look for a sensor para mabasa nyo ng tama yung signal natin. Okay? So, ayun, yun yung isa yung i-consider dito. Okay. Now, to process analog signals using a digital signal processor na magikwento kanina, an analog to digital converter which can be depicted using A/D o kaya ADC, okay, is required to be added to the system. So after processing, the digital output of the processor can be saved in digital format or can be converted back to analog using a digital to analog converter. So ito yung kompletong system natin. If you're starting from the analog input signal, you can have an AD converter, okay, in which it produces input digital signal. Now, a digital signal processor would process this input digital signal, okay, and then would produce a different processed digital signal. Now, at this point, dalawa yung pwede nyo kasing gawin dito. Maaari kasing ang load ninyo is also digital. Okay? Maaaring ang load nyo is digital. For example, LED. LED yung magiging output ninyo. So, digital yun. Okay? Or, isa-save nyo siya sa isang hard drive. Yung output signal niyo isa-save nyo sa hard drive. So you need to keep the signal to be in digital form in order for you to drive a digital output or to save the signal in digital format. So there is no need for you to do digital to analog conversion. But if you are to drive an analog load, for example, speaker. Yan. You need to convert yung digital signal into analog kasi hindi naman unless digital yung speaker ninyo. Pero speaker basically analog signal analog devices eh. Kasi magnet yan eh. It converts electrical signals to sound with the use of magnets. Okay? Although hindi ako masyadong familiar kung meron pang ibang mechanism by which sound is produced from electrical input. Okay, but basically, kung ang speaker niyo ay analog, okay, you need to convert this digital signal into an analog signal using a DA converter. Okay? Again, kapag ang output niyo, kapag ang load niyo ay digital, there is no need for you to convert it to analog. Okay? But if your output is analog, such as speaker, then kailangan nyo convert yung digital papuntang analog. Is that clear? Okay, so advantages of digital over analog signal processing. Medyo papasadahan ko lang ito ng konti. So, A digital programmable system allows flexibility in reconfiguring the digital signal processing operations simply by changing the program. Nabanggit ko na ito kanina. Because of tolerances of analog circuit components, digital systems tend to be more accurate. Okay, nabanggit ko na rin ito kanina. Even though the analog to digital conversion produces inaccuracies in signals. Digital signals can easily be stored in magnetic or solid-state media and can be processed offline. Okay? Digital signal processing allows for the implementation of more sophisticated signal processing algorithms. Kung gusto niyo mag-process pa ng in fact, most of the technology that we are using today, like for example, yung 4G, 5G, yung mga yan, yung Wi-Fi, most of this have been successful in delivering large data rate because of the more complicated digital signal processing algorithms that it can do. And those are not possible with analog signal processing. So that is why malaki yung naibibigay na advantage at digital signal processing actually pushes the delivery of the content more further than before. Okay. Because of the availability of very large-scale integration of circuits in small chips and their programmability, digital processors tend to be cheaper than its analog counterparts most of the time. Okay. In fact, at this point, mas mura na siya talaga. Hindi lang basta most of the time. Ngayon, mas mura na siya talaga. Okay. However, it should be noted that digital processing is not the ultimate solution to all signal processing tasks. An analog signal with a very wide bandwidth requires fast sampling rate AD converters and fast signal processors. There are limitations to the capability of circuits in terms of fast processing of signals. Thus, they may not be able to keep up with the requirements of processing wide bandwidth signals. That is why, yun nga, minsan ang option is to employ mixed signal processing. There is a limit on the bandwidth that can be done with simple digital signal processors. May limit talaga siya. But more specialized application can actually be more specialized applications requiring large bandwidths can actually be parang pwede ka mag-design ng processor para sa mga ganong applications. Yung mataas yung bandwidth. Okay? Is this clear with you? Alam niyo, I was intending to discuss these lessons today. 8:31 na, nasa 1 point pa lang tayo. So anyway. By the way, on Monday pala, it's likely na baka mag-asynchronous tayo sa Monday. Although inform ko kayo by Sunday night kasi meron kasi ako meeting by 10 AM nung time na 'yon. And medyo may kailangan akong i-prepare. So that is why I was thinking na baka mag-asynchronous learning mode tayo muna. Anyway, dahil nga sa hindi ko matatapos itong lesson natin for today, it's likely that I'd leave this readings up to you. Okay. Again, wala pa akong iniiwan na assignment . Although within the week, I'll try to post the assignment. I'll try to post the assignment. Okay. And pero hindi ko muna siya i-assign, or kung i-assign ko siya, wala pang deadline. Okay? Now, kapag may oras kayo, gawin niyo na siya kasi again, matatambakan na naman kayo. Okay? At kapag wala, pag wala pa kayong oras, edi iwan niyo muna siya. Gawin niyo muna yung ibang mas importanteng dapat niyong gawin muna. Okay? Ito lang yung medyo request ko, One thing that I would like to request from you. Medyo napansin ko kasi especially sa mga naging students ko last term sa advanced math. you have this this tendency of not completely reading the materials provided to you. Meron kayong ganong tendency. Halimbawa, merong binigay na quiz or ano sa inyo. Quiz or homework sa inyo. And this is especially true kapag iniwan sa inyo yung kumbaga hindi nagkaroon ng live discussion regarding dun sa material. Okay? You have this tendency of parang hindi niyo babasahin kung ano yung nasa reading material. And sasagutan niyo yung quiz or yung homework ninyo using a reference na merong difference dun sa reference na ginagamit natin. Ang classic example niyan is ito. Sa mga estudyante ko especially sa mga estudyante ko sa Advanced Math Cluster. Ang classic example niyan is yung Fourier transform. Kasi maraming formula ang Fourier transform, sa totoo lang. Maraming formula ang Fourier transform, hindi lang isa. Okay? It's just that yung ginamit kong formula is based on dun sa reference na ginagamit natin sa Advanced Math. It seems like yung ginamit yung reference sa pagkuha nyo ng sagot sa inyong assignment at sa inyong homework at inyong quizzes, okay? At inyong final exams. Hindi nyo kinonsolidate dun sa natin, sa reference natin. Paano ko siya napansin? Ang ginamit yung formula, yung walang kasi ang ginamit kong formula sa reference natin is ganito. Unang-una, ang ginagamit kong variable omega. May gumagamit sa inyo dito S. Ayun. Tapos pangalawa, meron akong normalization factor na 1/2 pi. Integral of negative infinity to positive infinity ng f of x e raised to negative I omega t. W pa ito, sorry. Hindi omega. Wt dt. Sorry, x pala. Yan yung nasa reference ko. Yan yung nasa reference na binigay ko sa inyo. Okay. Ang ginagamit yung formula ganito. Sorry, hindi pala to W. S pala siya. Okay. Ito yung ginagamit ko sa reference ko. Ito yung ginamit niyo sa sagot niyo. Okay. Gusto ko lang i-point out na parehong tama yan eh. Okay. Parehong tama yan actually. Maliban lang sa paggamit ng S. Kasi hindi pa ako nakakita ng reference sa Hindi pa ako nakakita ng reference sa Fourier transform na gumamit ng S as a variable. Ang ginagamit is either J omega o kaya omega. Yan lang yung dalawang nakita kong ginagamit. Pero ang S exclusively ginagamit sa Laplace transform. So, ayan. So, kaya medyo nalaman ko na medyo hindi kayo nagre-refer kumbaga, uunahin yung kunin yung nasa reference ninyo that tells you the answer kesa dun sa reference na binigay sa inyo. So, ganito one thing that you really need to remember is this. Sana baguhin natin yung habit natin of always trying to get the correct answer rather than learning on how to get the correct answer. Ang gusto natin kasi mangyari is i-present natin sa teacher natin na ito yung sagot namin. So, para masabi na tama siya. Okay. Eh, ang problema kasi, sa akin lalo na sa akin, I'm not really particular with the correct answer. I'm really particular with how you are trying to get the correct answer. And part of that is me, okay? Part of that is me trying to look out on how you are actually using yung references na binibigay sa inyo. Actually, hindi lang yan. Pati doon sa power series. Doon sa power series, doon sa test ng series, pagte-test ng convergence ng series, iba rin yung ginagamit yung reference. So, ayun. Sa mga naging estudyante ko ng advanced math last time, check nyo mabuti yung mga binigay ko sa inyong mga papers. Tingnan nyo kung ano yung mga na-point ko doon na parang kakaiba doon sa mga nakita ko. Okay. So, yun din. Sa iba naman, yun din naman yung yung gusto ko i-point out. Kung wala namang masama kung titingin kayo sa ibang reference. Hindi ko naman sinasabing bawal tumingin sa ibang reference. Bawal tumingin ng ibang reference. Okay lang 'yun. Okay. What I'm trying to say is, pag tingin niyo sa ibang reference, tingnan niyo rin yung reference na ginagamit natin. Just for you to consolidate the two. Okay? Just for you to consolidate the two. And syempre, yung standard na ginagamit natin sa pagko-communicate when it comes to trying to do things is yung nasa reference natin. So therefore, ang titingnan ko lagi, ang hahanapin ko lagi is yung nasa reference natin, yung notations na ginagamit natin. For example, ito pa. Ginagamit nyo yung ang ginagamit kong notation ng unit step function is u of t. Ang ginagamit yung notation para dito is h of t. Hindi ko tinuro yung h of t na yan. So, sana doon man lang, kinonsolidate nyo man lang na yung mga h of t ninyo, kinonvert nyo sa u of t. Mga tipong ganun lang. Small things, but these are the things that kasi ang principle ko dyan is we are trying to communicate on a common language. So, kapag medyo may iba kayong kino-communicate sa akin na hindi ko tinuro, although tama naman siya, hindi ko naman sasabing mali. Okay. Kaya lang, hindi ko kasi siya, wala kasi sa reference na ginagamit natin. Then there's something with the communication. Kasi nga, ginagawa nga rin standard yung pagko-communicate. Alam nyo ba na tinatry ko rin siyang i-standardize all across the courses na ino-offer? For example, yung Laplace transform na reference ko na ginagamit sa advanced math ninyo, at saka yung Laplace transform na ginagamit ko na reference sa control systems, for example, magkaiba. Ang ginawa ko, kinonsolidate ko yung dalawang yun. Tapos yun yung ginagamit ko material sa parehong course. Ganun din sa Fourier transform. So, it takes a lot of effort for me to consolidate things. Okay. So sana tingnan niyo rin mabuti yung binibigay sa inyong mga references. Okay? And also another thing. I'm now trying to yung mga examples na nakikita niyo dito sa For example, ito. Kasi feeling ko baka matapos tong time natin, nandito lang ako sa discussion natin. So, at least maiiwan ko sa inyo yung 1.2, 1.3, 1.4. At least meron kayong guide kung paano siya susundan. For example, ito pala. Ayan. Sa isang example, ito siya. Example 1.3. Ito yung questions. Hindi. Huwag pala yan. Ito. Ito yung mga questions. Okay. Pansinin nyo mabuti na ngayon, tinatry ko nang i-discuss yung solution. Before, binibigay ko lang yung sagot eh. But now, I'm trying to discuss the solutions. Okay? So, number one, I would like you to follow this I would like to follow this the solutions. Okay, based dun sa binigay kong discussion dito. And number 2, ito kasi yung gusto kong maging template nyo sa ito yung gusto kong maging parang manner ninyo by which you actually write your report. So parang yan na yung mga examples ito yung parang gusto kong makita dun sa mga report nyo kapag ka-discuss nyo siya. Nagkakaintindihan tayo? So, yung mga yan, nasa libro yan. Pero hindi ganyan yung pagkaka-discuss sa libro. Okay, that is not the way it was discussed on the So, niligyan ko yan ng sarili nating flavor. Kumbaga, in order for us to be able to understand. Kasi gusto ko nga pagka nag-usap tayo sa report ninyo, nagkakaintindihan tayo. Malinaw sa ating lahat yung At pareho tayo ng notations na ginagamit. Hindi yung meron kayong sariling notation, meron akong sariling notation. Para saan pat nagkaroon pa tayo ng course materials, hindi magkanya-kanya na lang din tayo sana. 'Di ba? Yun yung isang napansin ko sa inyo dun sa inyong mga submissions before. Okay. And dun sa mga hindi ko naman naging estudyante pa at ngayon ko pala naging estudyante. Yun. Warning yun sa inyo na I am reading reports. Nagbabasa ako ng reports at nagbibigay ako ng feedback. So I don't really like you straying from the guidelines that I have provided you when you write your reports. I have been providing many examples on how to write your reports. Starting with yun nga. Meron kayong guide on how to write your report here. Okay, meron kayong guide on how to write your report there. And number 2, yung mga examples na makikita nyo dito. Merong may mga discussions yan which I would like to serve as a template. Okay, for you, as examples for you on how you could actually write your own reports. Okay? Is that clear? Okay, so ayun nga, as I was saying, baka sa Monday, baka hindi tayo makapag-online session. Basically because may meeting akong I have to attend a meeting that's about a research na ginagawa namin ng wife ko. Meron kaming ginagawa kasing study. May kailangan kaming i-plancha dun sa mga aming mga data enumerators, yung kumukuha ng data para sa amin. So I need to do some evaluation ng ginawa nilang data gathering. And that would be on Monday mga around 10. May mga kailangan pa akong kailangan kasi ako i-prepare prior the meeting. So baka yun nga. So it's probably that on Monday we will have asynchronous learning, we will shift on asynchronous learning mode. And I'm expecting that by Monday tapos na kayo dito sa topic 1. Because when we come back next week, Thursday, we will be starting on topic 2 na. Okay? So, ito. Kaya medyo sa ngayon wala rin ako motivation na mag-record kasi ganun, yun yung nangyari last time na nag-record ako sa lalo na sa series. Ganun din, wala rin naman masyadong nanood. Anyway, so ayun. So, classification of signals. The method of characterizing and analyzing signals depends on their attributes. Thus, any study or investigation of signals should start with the classification of the signal. In order for you to carry out analysis and characterization of signals, kailangan alam natin kung paano siya i-classify. Okay? We need to obtain some basic information about the signals. Okay. So we start with multi-channel and multi-dimensional signals. Dimension okay, pertains to the number of variables. Okay? So when you say a signal is one-dimensional, mali yung spelling ko ng dimension. One-dimensional. Yan. When you say a signal is one-dimensional, it means that number of independent variables pa ito. Okay. So when you say a signal is one-dimensional, it means that there is only one independent variable. Or your signal is dependent on one variable only. Example niyan is a speech signal. Okay. Because a speech signal is only dependent on time. It only depends on time. So therefore, when you speak kasi, your speaking pattern changes. So therefore, these variations can be seen by looking at a signal as it varies through time. So therefore, a speech signal is a one-dimensional signal. Okay. When you say a signal is two-dimensional signal, it means there are two, or that means your signal is dependent on two independent variables. Okay? An example of that is an example of that is an image signal. Ang image signal kasi, although ang image signal is digital already, okay? Technically, magkaiba ang picture sa image. Technically, pero syempre, in everyday usage, pareho lang naman siya. Okay. Pero technically, magkaiba siya. Picture is analog, image is digital. Okay. Ang image, ganito siya. For example, yung image that are called bitmap images. Kasi maraming types of images Bitmap, JPEG, GIF, ito ba? PNG, and so on. Maraming types of images. So the simplest of them all is bitmap images. Kung ito yung image nyo, say ito yung image ninyo sa okay. What the bitmap image does is hinahati niya yan sa grid. Okay, hinahati niya yan sa grid. Yung isang cell nung grid na yun, halimbawa ito. You call this ang tawag niyo dito kung may idea kayo. Yung isang grid na to o isang element na to sa isang image.
Pixel po.
Pixel. Or that pixel actually stands for picture element. Okay. So since ang pixel ninyo changes in x and in y coordinate. Tapos yung signal niyo is basically the color information on each pixel. So kapag meron kayong image, titingnan niyo kung ano yung color information dun sa bawat isang pixel niyo. Now, one way to depict color is, for example, if you are using 8-bit bitmap, okay, you're representing each pixel with a number from 0 up to 255. Tama ba? 2 raised to 8 is 256. Tama ba? Hindi ako sigurado. 0, 1, 1, 2, 4, 8, 16, 32, 64, 128, tama, 256, 2 raised to 8, tama. So, i-represent niya yung isang color, isang pixel using a number between 0 to 255, which corresponds to the color. Yung 0 is black. Then yung 255 is yung white. Tapos yung anything in between is yung iba't ibang colors na. Okay? So as you change, as you move into another pixel. So again, the color information might change. So ibang number na naman yung gagamitin niyo to represent siya. Okay? So basically, you would have a grid of a table of numbers. Okay, representing yung color information on each pixel. That's bitmap. Kung JPEG yan, medyo mas komplikado ng konti yan. Okay? For one thing, JPEG divides your picture into three what we call channels. Mamaya pag-usapan ko ng channels. Yung red channel, yung green channel, at saka yung blue channel. So, iba yung matrix niya or iba yung table niya para sa red. Iba yung table niya para sa green channel. Iba yung table niya para sa blue channel. Then what the JPEG does is to flatten it. Okay. Pero essentially, ito rin yung basic idea nun. Na meron siyang grids called pixels. Tapos each one is represented by a color information. Pero ito, in the range of red. 0 hanggang 255. With this one, least red. Ito, most red. Okay? Ganun din to, 0 to 255, kung 8 bits yung representation niyo. But most colors, the most common JPEG na ginagamit ngayon is 24 bits. So it's 2 raised to 24 na representation. Anyway, so ganyan 'yon. So kaya siya two independent variables because the color information varies depending on the pixel location. Kaya dalawang dependent variable yung kailangan ninyong i-define in order for you to define yung image natin. Okay? Is that clear? Now, channel here, okay, refers to sources. Kung saan nanggaling yung signal niyo. In this case, sa case ng JPEG, technically, itong R, itong G, at saka itong B, these are channels. These are color channels. Okay? Although, this is not as explicit as what it is on an analog TV camera. Kasi sa analog TV camera, magkakahiwalay talaga yung channels na yan. Pero sa JPEG kasi, pwede nyo siyang paghiwalayin kung JPEG yung definition ng isang image. Okay? But an example of if you're obtaining your signal using one sensor on a location only. Say for example, may thermometer kayo sa isang tabi at binabasa niyo yung thermometer niyo on that corner of your room, for example. Then you have a one channel signal for your temperature reading. Okay. But if you're, say for example, dealing with multiple temperatures, multiple thermometers on your room. Tapos you're reading the temperature of the room using those different thermometers. Then you're getting your temperature signal from multiple channels. So you now have a multiple channel signal. Okay? Is that clear? Now, actually sinimulan ko yung discussion na to using yung tinatawag na real valued at saka yung complex valued signal. So obviously, kapag ang signal niyo ay defined using real numbers, it's a real valued signal. Pero kapag meron siyang complex part, or meron siyang imaginary part pala, then you can say that your signal is complex valued. Now, bakit kaya ako dyan nagsimula? It is because this complex valued signal can actually be used, okay, to define a multi-channel or a multi-dimensional signal. Okay? For example, maaaring itong signal nyo na to is a multi-channel signal. Okay? With the real part coming from one sensor. Okay? And the imaginary part coming from another sensor. Kaya lang merong requirement ito. If you have to use the complex representation to describe a multi-channel signal. The requirement is that the sources should be orthogonal. That is, they should be separated by 90 degrees. Kasi yun yung ginagawa ng J eh. It separates this part and this part, okay, by 90 degrees. Okay. Anong example niyan? Meron kayong accelerometer. Accelerometer actually measures acceleration. Okay. Now, one thing that you can read on an accelerometer is yung reading. Is yung velocity, is yung position signal, which I would explain on a later on a later discussion. Okay. Dahil 9 o'clock na, and I think may klase kayo ng 9 o'clock. So sige, I think I can release you na. Okay. So I'll inform you on Sunday if we are to have a synchronous session on Monday. Okay?
Okay po, sir. Thank you po.
So sige, tara na. Attend na kayo sa kabila niyong klase.
Thank you po.
Thank you din.